Okay, so today we are going to talk about the inverse trig functions, and we're just focusing on inverse, sine, cosine, and tangent. So in semester 1, we talked about how to find an inverse function and what an inverse function is. So to remind you of the notation, if we have a function f of x, the notation for the inverse function looks like that. So that's not the reciprocal. It does not mean 1 over f of x. It just stands for the inverse function of f of x. So what are some things that we know about a function and its inverse? So one thing that we talked about is that the graph is a reflection across the line y equals x. Another thing we talked about is that a function and its inverse, remember you swap the x and the y. So when we solved, we would switch the x and the y, and then we would solve for y. So when that happens, the domain and range are switched. Domain is our set of inputs and range is the set of outputs. So the inputs and outputs are being switched. And finally, a big thing that we talked about was one-to-one functions. This was in chapter 5. So if your function f of x passes, so remember, to be a function, it needs to pass the vertical line test. To be a one-to-one function, it would have to pass both the vertical line test and the horizontal line test. So if f of x, which is a function, passes the horizontal line test, that means, first of all, it means it's a one-to-one function. And second of all, it means that the inverse of f of x will be a function. Because if this one passes the horizontal line test, then this one will pass the vertical line test. So we're going to start with sine of x and its inverse function. So we're going to look at the graph of sine of x, which is right here. And I want to know, will the reflection across the line y equals x be a function? Why or why not? Well, as you can see, this sine of x fails the horizontal line test because the horizontal line is intersecting it more than once. So when you reflect it across y equals x, it's going to look more like this, and that will definitely fail the vertical line test. So let's say no, the reflection won't be a function because the graph of sine of x fails the horizontal line test. Well, so what do? Because we need inverse sine functions to help us solve certain problems. So in order to make the inverse of sine be a function, we are going to restrict the domain of sine. Which will allow it to pass the vertical line test. Or sorry, the horizontal line test. Okay, so the domain restriction that has been chosen, right, because we need this to be the same no matter where we're doing math. So the restriction that we choose is from negative pi over 2 to pi over 2, right? Because as soon as this comes back down, it automatically is going to fail. So this is the region that we choose to chop off before we find the inverse function. So we're going to restrict the domain to negative pi over 2 to pi over 2. So now instead of all real numbers, we are just looking at this one little piece of sine. And when we reflect across y equals x, we will end up with this graph here. So if you take this, if you swap the x and the y values, you will get this graph here. And this is the graph of inverse sine. This is the notation for inverse sine. There's another way to write it, which you can see here. So for the inverse sine function, you either write it with that little -1 or you write arc sine. I want you to get used to seeing it both ways. We will practice both ways. Sometimes you'll see, like, our textbook uses this one more, but some textbooks use this one more. So you just want to be familiar with both of them. So this is our inverse sine function. Now we're going to write down the domain and range. So the domain, remember, is a set of x values. It's stopping here and it's stopping here. So that's an x value of -1 to 1. So the domain is -1 to 1, included, both included, and the range is negative pi over 2 to pi over 2, which was the restriction that we chose for the domain. Notice the domain and range got switched. So this domain was negative pi over 2 to pi over 2. This range was -1 to 1. Now the domain and range have been swapped. So the output of an inverse sine function has to be between these values. So if and it will make more sense when we do an example, and it does take practice, but when I ask you to find inverse sine of something, the answer has to be between these two numbers. So anytime you give an answer, it has to be between negative pi over 2 and pi over 2. Now, we're going to be using our unit circle, so I'm going to show you that here. So where is it negative pi over 2 on the unit circle? It's not written down, but remember, this is positive pi over 2, so negative pi over 2 would be right here. So we need to be between those two angles. So starting here, coming around, and coming up here. So the answer has to be between those. Is 11 pi over 6 between negative pi over 2 and pi over 2? The answer is no. That is bigger than pi over 2, right? So instead of, when we answer these questions, instead of saying 11 pi over 6, we would call this angle negative pi over 6. So you want to imagine coming down into the negatives and then coming up and stopping at positive pi over 2. So visually, these are the angles that are in quadrants 1 and 4. And again, for quadrant 4, we're thinking negative angles. So let's do two examples. If I want to find the exact value of an inverse function, let's set it up like this. The output of an inverse trig function is an angle. So we are not used to seeing this. What we are used to seeing is, and I'll write it down here, we're used to seeing like sine of pi over 3 equals, what is sine of pi over 3? It's root 3 over 2. So now we're going backwards. So here the inputs are the angles, and then the output is a ratio. Now the input is the ratio, and we have to answer the angle. So the question here is, what angle would give us sine equals -1/2? So if it helps you, you could rearrange it. Sine of what equals -1/2, remembering that this question mark has to be between negative pi over 2 and pi over 2. So we're going to look at our unit circle. Where does sine equal -1/2? Staying in this region. So I'm going to go, sine is y, none of those are negative, it's going to have to be down here. Here is where sine is -1 over 2. That's the angle that I see as 11 pi over 6. But instead of writing my answer as 11 pi over 6, I need to write negative pi over 6 because it has to be between negative pi over 2 and pi over 2. Notice I'm not even bothering to come over here because that is definitely not between negative pi over 2 and pi over 2. So you are ignoring this half of the circle when you are dealing with inverse sine and only looking over here. So my answer is negative pi over 6. Same idea here. This equals question mark, and this is that other notation. It's the same thing. They mean the same thing. Sine of question mark equals root 3 over 2. You don't have to write this step. It can just help you think about it as you're getting used to these problems. And we already kind of answered that one. So sine of what angle is root 3 over 2? Only looking on this half of the circle. There it is, pi over 3. Is pi over 3 between negative pi over 2 and pi over 2? Yes, it is. So that would be your final answer. So now we're just going to apply the same concept to cosine and tangent. So I'm going to go through it a little bit faster because it's the same idea. So since the graph of cosine does not pass the horizontal line test, the reflection across y equals x will not be a function. So we're going to restrict the domain to, okay, hold on, someone's knocking at my door. You can fast forward this part of the video. I just got a Valentine's gift delivered. Okay, so we're going to restrict the domain of this one. It's going to be a little bit different. So let's see. Let's label our graph cosine of x. We're going to restrict the domain to, instead of negative pi over 2 to pi over 2, that's not going to work for this one because that will still fail the horizontal line test. So instead for cosine, we choose here to here. So that is 0 to pi. Now we're going to do the same thing. We're going to reflect across y equals x, and we end up with this graph, which is going to be the inverse cosine graph. So that's what the inverse cosine graph looks like. I would want you to know just what the basic one looks like, but we aren't going to graph transformations of these, so you don't need to worry too much. We'll more just be doing the algebraic part. So what is the domain of this? It's negative 1 to 1, so same as inverse sine. And the range is 0 to pi. Different from sine. So remember, sine was negative pi over 2 to pi over 2. Cosine is 0 to pi. That means that the output, so any of your answers to the inverse cosine problems, need to be an angle between 0 and pi. So where is 0 to pi on the unit circle? 0 is here, pi is here. So now I'm ignoring the bottom half. I'm only looking up here. And for cosine, we don't have to deal with negative angles. It's always going to be these positive ones. So these are quadrants 1 and 2. Find the exact value of an inverse function, and here we're practicing now with cosine. So again, these are the two notations. One way to do it is to put that question mark. Cosine of question mark equals negative 1. Where does cosine equal negative 1? Between 0 and pi. So this question mark needs to be between 0 and pi. So first, where does cosine equal negative 1? Cosine's x. There it is. There's pi. Pi is between 0 and pi because we are including those two. So your answer is the angle pi. I do want you to answer these in radians, not degrees, so that we can keep practicing, but like technically that's the same as 180 degrees. And then inverse cosine of negative root 2 over 2. So where does cosine equal root 2 over 2? Sorry, negative root 2 over 2. So if we look, here it is. Again, I'm ignoring the bottom half. So my answer would be 3 pi over 4. Okay, so that's cosine. So for tangent, it's going to go back similar to sine. So sine, we are in quadrants 1 and 4. cosine, we're in quadrants 1 and 2. Tangent, let's see what happens. So this is just saying the same thing as the other page. The graph of tangent does not pass the horizontal line test, so the reflection will not be a function, but we want it to be a function, so we will restrict the domain. And our choice here is this middle one. So the one that passes through the origin, this is what we restrict our domain to. Tangent's a little bit different because of the asymptotes. So the difference is that we're doing from negative pi over 2 to pi over 2, but those are not going to be included. So I'm using parentheses instead of brackets. Then again, we're reflecting across y equals x. Let's label our graphs. This is tangent, and this is inverse tangent. And so these two asymptotes, they're not drawn on here, but you can kind of see now they turn into horizontal asymptotes, which will help us to answer the domain and range. So for tangent, this is going to keep going on and on forever, right? So the range of tangent was all real numbers, so that the domain of inverse tangent is going to be all real numbers. Or you could use that symbol. The range is going to be negative pi over 2 to pi over 2, where those are not included. Okay, so that's what this is saying. Your answer for tangent needs to be between negative pi over 2 and pi over 2, but not included, because that's where tangent would be undefined anyway. So visually, these are the angles in quadrants 1 and 4. So same as sine, still between negative pi over 2 and pi over 2, so over here. Find the exact value of an inverse function again, now dealing with tangent, so arctangent. So the question here is tangent of what will equal 0? Tangent of what will equal 0? And I'm looking over here. So remember we wrote our tangent values. There it is. This is where tangent equals 0, and my answer should be an angle. So my answer is 0. Now where does tangent equal negative root 3? Well, I didn't write all of them, but here tangent is positive root 3. Down here, tangent is negative, so if this is tangent positive root 3, this is going to be tangent is negative root 3. Let's write those in. My answer should be an angle, and my answer should not be 5 pi over 3. It needs to be a negative angle here, so that's going to be the same as negative pi over 3. So see how here I'm not showing any work. You don't have to show work for these ones. Okay, final thing that we have, solve an equation containing an inverse trig function. So we did solve equations before that had an inverse function. We did it with like log and exponential functions. The idea is that first you want to isolate the function and the input. So if there's anything like a multiplication out here, or if there was like a +1 here, you'd want to get rid of those first. You want to isolate this part. So to do that, we're going to divide both sides by 3. Now I have inverse cosine of 2x equals 2 pi over 3. And that's a little strange to think about, right? Because I can't find cosine inverse of 2x. So if my variable is in there, I want to get it out. How can I get it out of there? Well, I can switch my input and my output, and I can change this to its inverse. So the inverse of inverse cosine would just be cosine. So we're going to change this function to cosine. And we're going to switch the input and the output. Right? That's basically what we were doing here. If we said this equals question mark, this was the output, this was the input, we changed it from the inverse to the regular, and we swapped the input and the output. Now you can either do this first, or you could divide by the 2. So I'm going to come up here, I'm going to divide both sides by 2, and I get x equals cosine of 2 pi over 3, and then divided by 2. Do not divide this by 2. It's this whole thing divided by 2. So we need to find cosine of 2 pi over 3. Use your unit circle. Here's 2 pi over 3. Cosine is the x value. It's -1/2. So cosine of 2 pi over 3 is -1/2, and then you divide that by 2. So you cannot bring the 2 in here. That's what some people are tempted to do. And -1/2 divided by 2 is -1/4. So that's it. Your homework is a handout. Actually, I want to show you one more thing. Let me grab the calculator. So you can, if it's angles on the unit circle, then you want to use the unit circle. So like, let's say I asked you, we'll use tangent as an example, inverse tangent of -√3. To get inverse tangent on the calculator, it's above tangent. So you hit the second, and then it shows up like that, and then you would type in -√3, and you get your answer. See how it's giving you your answer in decimal form, but that's going to be equivalent to -π/3. So there, I put a couple in the homework where it's not a number that we have on the unit circle. So like, what if I asked you inverse cosine of like 0.7? You could just type that into the calculator, get an answer, and round it. So I just wanted to show you how to do it on the calculator. There are a few on the homework that say use a calculator. For all of the ones that say and you get an exact value, you don't use the calculator. But you can do this on these calculators, and you can also do it on the little yellow calculators. They have the same function, so you don't have to use the graphing calculator. But that's all. I hope that you are understanding it. It does take practice, just like everything in math, but the most important thing to remember is that you do need to pay attention to which quadrants your angles are in, and anytime we're dealing with quadrant 4 for sine or tangent, you need to call these angles negative angles because we need our output to be between -π/2 and π/2. That is one of the most common mistakes I see in chapter 7. So go ahead and start the homework, and I will see you soon.